In this video, I'm going to do some examples applying Sakatoa. So, given this first triangle, or first example, and let me repeat, it's a right angle triangle because of that right angle. So all we're doing is identifying opposite, hypotenuse, and adjacent. Right. So the first thing that is the easiest to do is the hypotenuse. The reason is because hypotenuse, when you see a triangle, it's typically the longest side, but we don't know the labels of it, and you can never assume just by looking at a picture which one's the longest side. Sometimes they might trick you, so you just have to use the information that you know. So for example, in this right triangle, in order to find the hypotenuse is always the opposite side of the right angle. So right here is the right angle. So the opposite side is right here. So across from the right angle or opposite of the right angle is the hypotenuse. So I'm going to write the hypotenuse right here. So once I got hypotenuse out the way, so the only thing I have left is sine and cosine. Well, let me repeat. I'm actually doing opposite and adjacent. Now, we have this right angle right here. We have another one called angle theta. We use this symbol for angle when we don't know the measure of it, or the angle measure of it. So, going from this, we use the definition of for sine and cosine because opposite and adjacent. We already have hypotenuse, we don't need that. Alright. Now, from here, opposite and adjacent is pretty much straightforward. Opposite means across, and adjacent means next to the angle. So, let's do opposite. So opposite means across from the angle. So if this is our angle, what is across, what is opposite, is this side right here. So this is going to be opposite. And then for adjacent is the side that's next to the angle. So first, we have an example like this, and if you were to label, or if you were to identify your sides, always start with hypotenuse. Hypotenuse is always across, opposite of the right angle, so hypotenuse here. Then using this angle, if I were to identify which one is my opposite, it's always going to be across from it. So here's my opposite side, and then my adjacent is always going to be next to the angle theta. Now the reason I want you to do hypotenuse first is because you see how hypotenuse is next to this angle, and then we have adjacent. Even though the definition of adjacent means next to, hypotenuse is different because it's across from the right angle, it's the longest side. Adjacent means the other side next to the angle, the side that is not the hypotenuse next to the angle. So that's the difference between hypotenuse and adjacent. Hypotenuse is the longest side across from the right angle. Make a note of that. Adjacent is the side next to the angle theta. Alright, so in this second example, let's try to identify all the sides using the information that was explained and shown here. So the first step is I look at the right angle, and I look for the side that's opposite, which is this one right here. So that would be my hypotenuse. Alright, now I'm looking from my angle theta. So here I can see that this side is across from angle theta. So this side will be my opposite. Then this side is next to angle theta, so this will be adjacent. So that's all you have to do in labeling your sides of the right triangle. So first, hypotenuse, then according to your angle theta, label your opposite and your adjacent sides.